A signal from deep space, a planet that defies all expectations and a race to another star. What if all we thought we knew about the universe is about to be shattered? The James Webb Space Telescope, JWST, has uncovered secrets so shocking that they could rewrite the rules of life itself. But is Proxima B truly a new Earth or a deadly trap in the vastness of space? The James Webb Space Telescope, often hailed as humanity's highest tech instrument in the sky, has recently shifted its focus to one of the most intriguing exoplanets ever discovered. Proxima B, this distant world orbiting the red dwarf star Proxima Centauri, has captivated scientists and enthusiasts alike since its discovery. But now, with the unparalleled capabilities of the JWST, we can finally take a closer look at this mysterious planet. The revelations are nothing less than extraordinary. Proxima B was first discovered in 2016, but it was not until the James Webb Space Telescope came into the picture that we could truly savor the contents of this faraway world. The telescope's ability to capture infrared images of Proxima B's atmosphere, revealing previously unknown details hidden from view, has sparked excitement and concern. Proxima B revolves around its star at an incredibly close distance, just 7.3 million kilometers away, which is less than 5% of the distance between Earth and the Sun. This proximity means that the planet completes a full orbit in just 11 point-to-Earth days. Even more fascinating is the fact that Proxima Centauri, the star it orbits, is a red dwarf. Unlike our Sun, which is a relatively stable star, red dwarfs are known for being volatile, frequently emitting powerful solar flares that can drastically affect the planets orbiting them. Now, here's where things get even more interesting. The JWST has provided the clearest view yet of Proxima B, and it has revealed some startling features. For one, the planet is about 30% more massive than Earth, which means it has a stronger gravitational pull. But what's truly shocking is the possibility that Proxima B is tidally locked with its star. This means that one side of the planet is continuously illuminated while the other is shrouded in eternal darkness. Imagine a world where the sun never sets on one side and the other is thrown into an interminable night. This tidal lock creates a harsh environment for any potential life forms. The side facing the star Proxima Centauri would be scorched by constant radiation. On the other hand, the dark side would be a frozen wasteland. This raises a critical question: can life exist in such extreme conditions? The possibility seems slim, but nature has a way of surprising us. The challenges don't stop there. Proxima Centauri itself poses a significant threat to the habitability of Proxima B. The JWST has revealed that the star is much more energetic than previously thought. Its powerful magnetic fields produce intense solar flares that bombard Proxima B with high-energy radiation. In fact, in April 2021, a flare 100 times more powerful than any flare ever seen from our Sun was observed. This enormous outburst of energy could strip away the planet's atmosphere, leaving it exposed to the harshness of space. Some researchers argue that the star's proximity and frequent solar flares make it unlikely to support life as we know it. Others, however, suggest that life might find a way to adapt to these extreme conditions. Could there be organisms on Proxima B that have evolved to survive in such a volatile environment? Or is the planet doomed to remain a barren rock devoid of life? As we continue to explore Proxima B with the James Webb Space Telescope, more secrets are sure to be uncovered. But one thing is clear: this small planet, only 4.2 light-years away from us, is far more complex and mysterious than we had ever imagined. Could it be that Proxima B holds the key to comprehending life's limitations in the universe? If so, what does that imply for our search for extraterrestrial life? Among Proxima B's stunning secrets was the planet's atmosphere, or rather the potential lack thereof. The intense radiation from Proxima Centauri, combined with the planet's close orbit, means that Proxima B is constantly bombarded by solar wind and high-energy particles. Over time, this relentless assault could have stripped away the planet's atmosphere, leaving it barren and exposed to the cold vacuum of space. But here's where things get interesting. Some researchers think that Proxima B might still retain a thin atmosphere, which may be composed of heavier gases like nitrogen or carbon dioxide, providing some protection from the star's radiation. The James Webb Space Telescope has provided us with the clearest glimpse yet of Proxima B's surface, and what it has revealed is both fascinating and mysterious. The planet's surface appears to be rocky, much like Earth's, but with significant differences. For instance, the side of the planet facing Proxima Centauri has probably been burned by constant heat, creating a barren landscape resembling a desert. Meanwhile, the planet's dark side could be an ice-covered desert with temperatures far lower than anything experienced on Earth. The most intriguing possibility lies in the narrow strip of land between these two extremes, referred to as the twilight zone. This area, where day meets night, might provide a more temperate environment where water could be liquid. The existence of liquid water is, of course, one of the essential components of life as we know it. Could this twilight zone harbor a hidden oasis where life has taken root despite the harsh conditions on the rest of the planet? Another stunning discovery scientists have considered is the possibility of water on Proxima B. If water exists on the planet, it would likely be in the form of ice on the dark side or small, possibly temporary, bodies of liquid water in the twilight zone. However, the finding that surprised many was the potential for subsurface oceans similar to those on Europa or Enceladus in our own solar system. These oceans might be heated by the planet's core or by tidal forces caused by Proxima B's close orbit to its star. If such oceans exist, they would be a prime location to search for life beneath the planet's icy surface. But let's not forget the potential difficulties. The magnetic field of Proxima Centauri is another factor that increases the complexity of the planet's environment. Recent research indicates that the star's magnetic field could interact with the planet's core, generating its own magnetic field. This interaction might protect the planet's atmosphere from being completely stripped away by solar energy, much like Earth's magnetic field shields us from the sun's radiation. However, the situation on Proxima B is far from straightforward. The star's powerful flares could overwhelm the planet's magnetic defenses, leading to dramatic and sudden changes in the climate of the planet and conditions on the surface. These discoveries raise more questions than answers. Does Proxima B have a magnetic field? How strong is it? What effect does it have on the planet's potential and atmosphere for life? Could Proxima B's life have evolved to survive the planet's harsh and changing conditions? And if life does exist, how would it manifest? Would something completely different occur from anything we've seen on Earth? Or could it have in common with extremophiles that thrive in Earth's most inhospitable environments? A hostile world where life faces extreme challenges. While the idea of a habitable planet orbiting Proxima Centauri is captivating, the reality is far from hospitable. The James Webb Space Telescope has provided unparalleled insight into the challenges and any potential threats to life on Proxima B, and the picture is anything but rosy. One of the most significant challenges is the planet's exposure to extreme levels of radiation from Proxima Centauri. Unlike our Sun, Proxima Centauri is a red dwarf star with a much smaller mass and a much more chaotic surface. This star's proximity to Proxima B means that the planet is constantly bombarded with intense solar radiation, including powerful flares that can be 100 times stronger than those emitted by our Sun. These flares produce a deadly cocktail of ultraviolet and X-ray radiation that would be lethal to any life forms similar to those on Earth. The outcomes of this radiation are not just theoretical. In April 2021, a particularly massive flare from Proxima Centauri was detected, and it was strong enough to potentially strip away any atmosphere that might have existed on Proxima B. This event serves as a stark reminder of the dangers posed by red dwarf stars and raises questions about the possibility of Proxima B being a haven for life. Moreover, the regular exposure to this kind of radiation would make the surface of Proxima B an incredibly hostile environment. Any water on the surface would be rapidly vaporized, and the planet's rocky landscape would be scorched by the relentless heat. The dark side of the planet, while not exposed to direct radiation, would face the same challenges due to freezing temperatures. This extreme divide between the scorching day side and the bitterly cold night side leaves little room for a stable, life-sustaining environment. The race to reach Proxima Centauri begins. While the signal from Proxima Centauri remains a mystery, the idea of actually reaching the star system has moved from the realm of science fiction to a genuine scientific endeavor. The Breakthrough Starshot initiative, spearheaded by a team of visionary scientists and backed by prominent figures like Stephen Hawking and Yuri Milner, aims to send tiny, laser-propelled spacecraft to the Alpha Centauri system, including Proxima Centauri, within our lifetimes. The Breakthrough Starshot's concept is as revolutionary as it is ambitious. The plan involves launching thousands of tiny spacecraft, each about the size of a postage stamp, into space. These star chips would be propelled by powerful lasers, reaching speeds of up to 20% of the velocity of light. The objective is to send the spacecraft on a decades-long journey to Proxima Centauri, where they could return information about the star system and the planets within it, including Proxima B. While the challenges of such an endeavor are monumental, the potential rewards are equally vast. Discovering the true nature of Proxima B, whether it harbors life or is a barren, inhospitable world, could have significant repercussions for our understanding of life in the universe. What if Proxima B, this strange and volatile world, holds the key to comprehending the universe's life? The hunt for extraterrestrial life is one of humanity's most profound quests. But as our understanding of Proxima B and other distant worlds grows, we are confronted with the realization that life may not appear as we expect. Ultimately, Proxima B may not be the Earth-like paradise we imagined, but it may be a vital stepping stone in our quest for knowledge about the universe. The search for meaning in the universe is only just beginning, and Proxima B is leading the way. But the question remains: will we ever be able to uncover the secrets of Proxima B? Only time and the continued exploration by instruments like the James Webb Space Telescope and initiatives like Breakthrough Starshot will tell. Perhaps Proxima B, with all of its challenges, is not just a planet to be studied, but a glimpse into the future. The search for life, whether in our own solar system or on exoplanets far away, is a reflection of humanity's innate curiosity and desire to understand the cosmos. The discoveries made about Proxima B could shape the next generation of space exploration, providing crucial insights into the potential for life on distant worlds. But even if Proxima B proves to be hostile to life as we know it, the lessons we learn from this exoplanet could have significant effects on other planets out there. We may one day locate worlds that are more welcoming, more like our own Earth worlds where life has found a way to survive and thrive in the most difficult environments. The quest for knowledge will continue. Additionally, as we push the limits of space exploration, we will no doubt uncover yet more mysteries that will challenge our comprehension of the cosmos. In the end, Proxima B serves as both a symbol of the challenges we face in exploring other worlds and a reminder of the incredible possibilities that lie beyond. A planet that may or may not harbor life, its significance lies in the inquiries it raises and the journey it motivates. Through continued advancements in space technology and using tools like the James Webb Space Telescope, we are closer than ever to answering one of humanity's most profound questions: are we alone in the universe? The search for life may one day lead us to Proxima B or even further into the depths of space. And if we find life, whether microbial or something completely distinct, we will have taken a monumental step in understanding the vast, mysterious cosmos that we are just beginning to explore. Proxima B will continue to be a touchstone for our ambitions, inspiring the next wave of scientific discovery and exploration for generations to come.